So we've basically come back to what the classic product versions of LCC devices do, which is all of this configuration. So like the CDI XML, the configuration, and the storage. Now, this is pretty tricky on an Arduino. Well, except the old ones. For the old ones, it was very simple. But the new ones, the modern 32-bit Arduinos, they don't have EEPROM. So that classic storage that you would use for this purpose, it just doesn't exist there. They have Flash, but Flash cannot be used as it is because it would wear out too quickly. So really, you need some form of wear leveling file system. And unfortunately, in Arduino, there is no standard for storage. There is no standard for wear leveling file system. There is no POSIX layer or emulation layer. And the EEPROM library is only supported by relatively few platforms. Very few 32-bit platforms support the EEPROM library. And even those that actually support it, they have such a silly implementation that that's not doing any wear leveling at all. So it's basically not useful. Now, OpenMRN proper has an EEPROM emulation library. So with full OpenMRN, we have the ability, and we have actually done so. Like you can actually look at these products. We have done so. You have the ability to do wear leveling inside the built-in Flash. OpenMRNLite doesn't have the drivers, unfortunately. So that's basically the big difference, where we are relying on the Arduino core. And the Arduino core does not have a standard for storage drivers. And it's pretty tricky to get out of here. The ESP32 has a solution. And the ESP32, of course, it has an external flash chip in the ESP32 module. And there is a standard library called SPIFS, SPIFFS, which acts as a wear leveling file system. And this is a standard solution for ESP32. So we actually have adjusted to that and adapted to that. By the way, it's actually POSIX compatible. So we actually did not need to adapt to that. ESP32, even under Arduino, does provide POSIX compatible file systems, which is pretty cool, I suppose. And we are making extensive use of that. But the end result is that if you want like a classic I/O board, you really need to go to an ESP32 right now, or you have to go to OpenMRN proper and not use the Arduino ecosystem. So, but I'm happy to talk a little bit about the configuration and the CDI details, because this can be a little bit tricky to understand and reason about on OpenMRNLite. Because fundamentally in OpenMRN, you don't write the XML for your device. Instead, there is a meta description in a file. I call it usually config.h. It's a header file because you can include it in multiple different things. It's basically C++ code to describe what do you want in your configuration. There are pretty elaborate examples in the I/O boards, because of course the I/O boards have a lot of configuration because of all the configurable events. And what really happens is that OpenMRN actually writes the XML for you based on this source code. And not only does it write the XML for you, you also don't have to worry about the offsets, because the source code also specifies what the offsets are going to be in your EEPROM emulation or file or config file. So this basically means that with this mechanism, the offsets that you have in your storage and the XML that the device is serving up, they're always in sync. And that is actually a relatively tricky part of building LCC devices. I don't know how much experience you folks have with working with other types and other mechanisms, but making sure that your XML and your source code is actually describing the same storage layout, that is a challenge. So OpenMRN basically shortcuts this challenge by using the same source code for both the XML as well as whatever the actual C++ code does use from the offsets. Of course, whenever you upgrade the firmware, then of course both of them are going to change. So both your XML and your offsets could change if you upgrade the firmware. But this is true for any other mechanism for writing OpenLCB software. So basically, whenever you upgrade your firmware, you either have to wipe your storage at the beginning, for which we actually have a mechanism, or you need to somehow ensure that you didn't actually like shift everything, that your storage layout is somehow backwards compatible. Cool. So this is about how we deal with XML and CDI. And I'm going to go through a couple of like a little bit of hardware recommendations. Obviously, there is always a great overlap on what kind of hardware you can use for OpenLCB or LCC devices. So this is possibly not going to be a lot of surprise. One of my recommendations, if you want to do like absolutely no soldering, not building printed circuit boards, then you're basically limited to boards that have the built-in transceiver. And there are two great examples. Both are supported by OpenMRN. One of them is the Feather M4 CAN. This is an Adafruit Feather board, which actually comes with the transceiver, and you basically have the plug for CAN bus high, ground, and low. And that's great, and it works in OpenMRN, and it works very reliably, and it's nice. And you also get, I would say, a fair bunch of I/O pins if you want to build this into a layout or in some sort of motherboard or just put headers on it. The other one is which David just found and reported great success, which is this UCAN board, which can be used as a USB CAN adapter, and it costs like $4 or something like that. Sometimes even less than that on AliExpress, sometimes even like $2 or something. And this can be used as a USB to CAN converter. It has an STM32 F072. That's good enough for a USB CAN converter. Unfortunately, it doesn't really have any other pins than what is needed for CAN bus. So you can't really use it in the layout, even if it would be relatively cheap. But as a USB to CAN adapter, this is a great piece of hardware. Some testing still needs to be done, I believe, because I have found difficulties with the USB software that Arduino comes for the STM32. So I think there is a little bit of caution needed, and a little bit of testing would be well advised here. But from the hardware perspective, this is actually great. Now, if you are willing to build, appropriate motherboards and put down the CAN transceiver and put down the appropriate, sockets and connectors, etc., then my recommendation is to use the STM32 Nucleos. The Nucleo F091 and the F303 specifically. There are at least like 40 different Nucleos. But I recommend these two, and I am using these two pretty exclusively for OpenLCB and LCC purposes. And this also means that any kind of software that I write, I'm always testing on these two particular devices. I also recommend this chip for manufacturers to use in real production devices. So why Nucleo? This is what the Nucleo looks like. This is the white device on top here. It has an incredible number of pins. Like the package itself has 64 pins, so you have at least like 40, 50 GPIOs. So you can connect as many things as you really can think about. And you can connect them directly, and you don't have to, without having to worry about various expansion bus and I2Cs and everything. And the second very important component is that this device actually comes with a built-in emulator, so you actually can just connect it via USB, and it shows up as a flash drive, and you can copy paste the bin file to it, and it's going to flash over it. This USB also can also be used for a computer interface if you really want to. So you can get debug input from there, or you can use it as a USB CAN interface as well. Although I would not actually recommend using this as USB CAN in a real railroad, because this is not isolated. It ties together the computer's ground and the railroad's ground, and I think that's a really bad idea. And by the way, that's also true for this one. So this is really good as a super cheap USB CAN, but the ground is connected, and you have to be like really aware of that. If you buy any real production grade LCC USB adapters, so either from RR Circuits or from Andrew Crossland, those USB LCC adapters, they are actually going to have a galvanic isolation in there, and I find that is an extremely important part for connecting a computer to the railroad. You don't really know what kind of voltages are going around in the railroad, what kind of interferences, what happens in a short circuit situation, etc. Disconnecting the ground is a very important safety measure. Okay, so back to the Nucleo. This is my recommendation. You can build this into the layout, and you can connect it just purely via the CAN bus or the LCC bus. I have actually created a motherboard for that. And that motherboard is available for quote-unquote purchase, so you basically have to pay $1 for it. And the PCB manufacturer has it in their open hardware catalog. So this is an open hardware that you plug in the Nucleo, either of those two, and it provides a variety of different options that you can choose to populate or not populate. I think it has like 16 input lines. It has 16 high current output lines at the bottom, and it can operate four tortoises, or other slow motion switch machines, or you can use these other 8 outputs also to drive sort of like higher current objects, like LED strips or something like that. If you like to use servos, there are a couple of servo headers there as well. I think there are 8 in total, like 4 there, 2 there, another 2 here, and there are another 4 somewhere. I don't know where. So you have the ability to connect a variety of different types of equipment to this. And you basically get a baseboard, and then you decide what you want to solder onto it. And this is really like this is a full equipment. It also contains a switching power supply to actually power your microcontroller. So you won't have to worry about supplying external power, which can be pretty useful if you are building a layout and you have a large number of devices there that all need power. So that in that case, it's going to get power from the LCC cable. If you want, you can also use it as a power point. So you can plug in a DC wall wart, and then this becomes the power point, and it will supply power through the LCC cable to other devices like itself. So I highly recommend this. There are also these extremely cheap things called blue pill and sometimes black pill. So they are based on an STM32. So from that part, it's okay. The problem is most versions come with 64 kilobytes of flash, and 64 kilobytes is not going to run OpenMRN. might be running David's single thread library. It's probably going to fit the single thread library there. But you also probably are not going to have a lot more leftover space, so you can't put actually storage in there, and then it gets a little bit tricky. So that's for most of the blue pills. There are some blue pills that come with 128 kilobyte. That's going to work.
Yeah. Balazs, the other problem is that in a lot of them, you can't use the USB at the same time as CAN.
That's okay. Yes, that's also important. So they can't be used as USB CAN adapters. That's very important. But they can be used as devices in the layout.
Sure.
They're very cheap. They're very cheap. Like they are $2, $3, $4. There is also a black pill version, which has a beefier microcontroller, but unfortunately, that particular one does not have CAN bus. So the black pill doesn't work either. I have, however, found this strange thing, which has which looks like a blue pill, but it has like a Giga device, STM32 clone, and that one's actually fine. That one's actually an F303. So you have to dig a little bit on AliExpress, and eventually you will find something that is really cheap and it's actually going to work. Although I don't have a lot of experience with these Chinese clones of the STM32 microcontrollers, but who knows? They have a market, so they must be doing a job that is not absolutely terrible. And then finally, ESP32. Obviously, ESP32 is the platform that is best supported by OpenMRNLite because ESP32 actually has the built-in storage, right? And because it has the storage, you have the ability to do the CDI and the XML and the configurable producers, consumers. And for the ESP32, you can basically pick whatever you want because it really doesn't matter. But if you are interested in actual model railroad hardware, Robert Haller has done a large variety of open hardware and he basically published everything on GitHub. So there are all like schematics Gerber files there. And he even published a large variety of, he even published source code for a lot of these. And I just realized that literally half an hour ago. All of this source code is actually built on OpenMRNLite. So this means that the source code that are here actually happens to be a much better set of examples for OpenMRNLite than what I actually bundled with the library. So I don't know, maybe I'll try to pull this up and see if I can